Welcome back, everybody, to part 2. Well, you can see we're under the belly of the beast. In this part, we'll take it out of the cabinet, obviously, and we're going to start doing some troubleshooting, some continuity checks, and start looking for some of the things that we know could possibly be. One of the noted things that these radios were famous for failing, and no surprises, we do have some failures here. And so in this, we're going to go through it, do some things. And one of the things I want to emphasize is this radio is 100 years old. And let's think about this. This was early radio. So the ones that came after this in the late 20s, 30s, 40s, 50s was built upon this, what they learned from this. And one of the things we're going to find in here is connections, bad connections, and just the materials that was used, like steel lock washers. They rust, causes issues. And even if your radio's 60 years old or 50 years old, things break down. Corrosion is always something to be looking for. But we'll go through here, we'll do some continuity checks and everything, and then we've got I see a 3-step recovery plan. And we'll go over that a little later in the part. We're not going to get it to play in part 2. It'll be part 3. But I believe we can get it to play just to see that it will play. And then we have another plan after that to make it play better. And then there may be even one step further, and we'll talk a little more about that. And so instead of me just jabbering and whatever, let's get into part 2. Okay, let's pull this out of the cabinet. We've already talked about not having any screws in the front. I've removed the tubes, put them in a safe place, and there was 2 screws, one in each corner, that I've removed. And so I would like to think that this will slide out the front now. So let's there's something catching right here. I don't know. I don't want to force it. You don't want to break any plastic or anything like that. Let me examine this corner, because this corner looks like it's kind of stuck. Okay, this corner was stuck. I don't know. I used an X-Acto knife to go back in there to get it loose. So I see some things in here. I'm not sure. Okay. Let me set this over here, out of the way, and we'll look inside here. This looks like maybe this was supposed to be here. Maybe that's the way it's supposed to be, with another screw in there. That's what it appears. Now this one is loose, so apparently we're going to have to do some work inside here. Alright, let me lower this lid, and we will move this out of the way. Well, there we go. Yeah. The chimp can't figure it out, huh? Okay, I've set this back on here. And so let's take a look underneath here. Of course, this is all bakelite or plastic, both front and back. And we'll see what this looks like under here. Let me get you a better angle. Okay, what do we have here? This appears to be a replacement transformer. It's just because it looks newer. It's different in size. Let's see how this one is attached. This is attached by 2 screws with some standoffs. Yes, let me show you. This is a replacement. On this side, you can see this underneath this tag. This is the mounting screws for this transformer underneath here. And if we move over here, and there's always that garbage can in my way, here's the mounting holes for that transformer, the original one. And looks like they've drilled a couple of holes here to mount this other transformer, which not that bad. When I found a little knob just as a replacement until I can locate one like that, but I did find one. Let's look back under the bottom again. Well, it doesn't get much simpler than that, does it? You're talking about point-to-point wiring. Would look like 10 gauge wire. Couple of capacitors. They're labeled freshman, 0.005 and 0.002. And I'm just curious, I've never seen under one of these. For you guys out there, is that what came in this, or is this some reproduction that has been put in there? I would like to think, even if it is a reproduction, that's what the originals looked like. But it does look like this has been worked on, and apparently it had been repaired with this transformer. There's not a whole lot that can go wrong except tubes. Of course, rheostats. These look pretty good. Let's take a real close look at those. Okay, this is the amplifier rheostat. It looks in pretty good shape. Trying to see some nomenclature on it. What does that say? You guys can probably see better than me. Let's look at the other one. That's just some dirt. Thought we had a burr in there or something. It looks pretty good. But, you know, you look at it. It's contacts to the tube pins, a couple of capacitors, a couple of rheostats to control the voltage to the tubes. I mean, what can go wrong? So, we need a power supply. We need to fix that other tube. And maybe you have to order another tube. But I'm thinking, and y'all put your thinking caps on also. Let's pretend that all the tubes work. Then we should be able to run the loudspeaker. Y'all agree with that? I do. If the other one doesn't work, we should be able to still use the headphones, because The way I see it, this tube is only to run the amplifier for the loudspeaker. So we still should have a signal to this point. And if this transformer is good, and I've got to determine which is which, T1 or T2, which one is the new one. And we can track that down. Let me track that down and get back with you, and we'll figure out which one. Is it T1, T2 that's been replaced? I went through here and labeled according to this. This schematic has been, I think someone has updated this. Anyway, it shows the tubes as E1, 2, 3, 4, and 5. And then the capacitors are CL1, CL2, CL3. And those transformers are L1, L2, L3. So I numbered those. And so the tubes are E1, E2, E3, E4, E5. There's L1, C1, CL1, L2, CL2, L3, CL3. All right. Of course, your transformers are underneath. Let me show you what I found. And it's not good. Brace yourself. Okay, perhaps you can see. I've labeled the transformers T1, T2. If you'll look at this wire here, here's the sleeve that came off of it. Let's get a little light on it. As you can see, that has been hot and is burned off of this connection here. And when I check, you can see the discoloration. I checked the continuity of this one, nada. Continuity of, you can't see. I checked T1 and I checked T2. And I'm going to go back through there again and maybe do it on camera and check it. But I couldn't get any continuity on any of it. So maybe I was doing something wrong. So it's late, so I think I'll take a break, come back to it a little later. But I'm afraid these interstage transformers are bad. I believe we can get replacements. Don't know. But we will see. Let's check the these transformers. Here's T1. Let's check the primary. E3, which is 1, 2, 3, and the plate of E3. You see that? Comes down. And then it goes down to B plus detector, which is this connection here. So if we put it to here and to here, we should read continuity. And we got nada. I was expecting 2-3K maybe. Now these are DC resistances. The plate of this tube, the impedance of it is right around 10K, and then the grid of the tube is really high impedance. So we have to have a step up transformer, as you will, to match those impedances. Okay, so we're pretty sure that this is open, which they're all noted to do that. Now let's look at the secondary, which is the grid of E4, and it goes down to the A minus. Okay, E4 is 1, 2, 3, 4, and the grid, this is the plate, so this would be the grid. And how do I know? Because I drew it up there. I took the pin out of the tube and I drew it up there. Okay, so I'll check that there, excuse me, and then we'll go over here to the B minus. Okay, we don't get anything, we don't get nothing out of there either, but remember, it goes to from the grid down to the A minus. Well, let's trace this A minus down. It goes here, it comes across here, and if you'll remember, this wire had broke off there and had the little spaghetti on it here, and I showed you that was really hot. So it's not connected over here. So let's put this here and see what we get. We get right at 9K DC resistance, and since this wire is really cruddy looking because it's been hot, there's 9K. Okay, so the secondary is probably okay on this. A lot of good it does us. So let's do the same thing for the T2, which is over here. Hope you can see this. So the primary of it is E4, which we had already counted 1, 2, 3, 4. So we said this was the grid, so this is the plate. So we'll go ahead and put on the plate there. And then the plate of E4, and it runs down to the B plus on the amp, which is the very end. So we'll connect that there. And it's in your way, but it's open. So let's look at the secondary. It goes from the grid of E5, 1, 2, 3, 4, 5, and it goes and comes down to the A minus. So let's see, the grid of E5 and the A minus, and I documented as 8.27. It's showing 8.2K. So and that's what some of the numbers I've seen online, but the numbers on the primaries are somewhere around 4K, I believe. And typically I'm thinking this is 1 to 2.5 winding ratio. We'll confirm that a little later, but with so we're probably going to go back with a 1 to 3. Now here's my plan. I would really like to rewind these. You've seen me rewind small coils on Philcos and things like that. But as far as speaker coils, little transformers like this, I haven't wound any of those. I did in my early young days. It was really dumb, but I wound a 12-volt transformer for a power supply from a TV transformer. And I was on midnight shift. Dumb story, but I took it apart. I actually set it on fire to melt the tar so that I could get the laminations out. Didn't damage the windings. And then I went back and I went to the motor shop and begged some 13 gauge copper wire, and I calculated the windings and everything like that. Don't know how I done it. I really don't remember. I think I took and counted the numbers that was on like the 6.3 winding in there and calculated it and wound for which I was dumb. I should have center tapped it at 24, but I didn't. I'd wound it for 18, and I wound it and it ended up 18. And a friend of mine tested it and he put 50 amps on it, and he said it just exploded. But then after the smoke cleared, he went up there. The transformer was fine. It just the little tiny pigtails I had put on the 13 gauge wire had blowed off, but the transformer worked after that, and he used it for some other project. So that was my success for a transformer. But I would like to rewind these. So what I'm going to do is I've already ordered 2 inner stage transformers from Antique Electronic Supply out of Arizona, and which are fair replacements for these. And my plan is to take a piece of phenolic and drill holes where these mount. Actually, the original mounted on this one. Take and drill holes for it, and then mount the transformer on that piece of phenolic, so I don't have to re-drill or anything to this, and install this and get this working. Once we get this working, we will go back and explore rewinding these. And I want to get into rewinding from like Greg's Vintage Workshop. He built a good rewinder, and Don of Restore Old Radios, he's built a great rewinding machine, and I would like to build or do something along those lines so I could do these in the future. So, but I want to get this going. I just got word from Bob, everybody knows Bob, about the power supply that I have for the Zenith farm radio. He showed the modifications, how to get the volts out, and it should work. I just got to verify it, so I'm probably going to modify that to get this up and going once I get the transformers and everything in. And hopefully I can either revert that one back or purchase another one to go on the Zenith radio. So it's a juggling act. It's Radio Jenga at its finest. But anyway, you know, I had made comments that I didn't know if these were reproductions. I've seen other pictures. I went and did a lot more research. I did other pictures, and these are in other freshman masterpieces. And I've actually found a picture of one online that has a transformer like this and like this. It's almost like this one, except the capacitors were different. But apparently this was a time period replacement, because if you remember, I told you that the dealers would repair the radios, and the customers really didn't know much about whether or not the company was good or bad or what have you. But these are notorious. Every article I've read says these are almost always open, some form or fashion. Let's see. Let's check our rheostats. Let me stop this for a second. Also found this drawing schematic online on the amateur radio forums, and it has the values. It has the DC resistance 2K and 7.8K on this transformer, which they're all going to be different in the day, whatever. Now this one's a little bit different. This one shows 805.6K. So that's a little bit different than this one. But anyway, it shows the impedance of it. This one is 14K to 36K. And then this one's 3K to 36K. And I don't know that I understand, because what I can tell, they were supposed to be identical. I mean, 2 different stages, but they're same tubes, linking both the tubes. I may be missing something. Maybe someone out there can explain that to me. But here's the rheostats. One of them is a 6 ohm rheostat. The other one is 32 ohms. Let's verify this. Let's see, from here to here. is, well, if I get a good, that ain't what I'm wanting to see. Perhaps if I were to move it. Well, that's sweet, isn't it? The chimp. All right. There's 29. It's supposed to be like 32. Now, when you get to the end, there's no windings, and so it drops off the deep end up there. So there's the 32 ohm one, and the other one is the 6 ohm. So we just leave that on there and that on there. Why am I clipping it on there? Boy, you're brilliant, aren't you? So anyway, but this one has the on-off switch. So we'll go up here, and we should be getting, well, close to 6 up here. I think you can see that. And here's your on, here's your off switch. See how it flips off here? Let's see, maybe you didn't see that, but this is your off switch. See how the wiper drops off there. Okay, so these rheostats are okay. So we have these two bad apples that we got replacements coming for right now, and we got to fix that tube. And what concerns me is the tubes. I don't know how to check them other than put them in there. So I'm going to be thinking about maybe I can rig up some current meter when I bring this up and make sure that I'm not overcurrenting, because these transformers, that the replacements are rated at 10 milliamps, and a good tube should not pull over 10 milliamps. Shouldn't even come close, probably 6 or so. But we'll have to figure that out. Of course, all this stuff is doing research, and that to me, that's a lot of the fun and everything. So all right, I'm going for now, and I'll bring you back when there's new developments. I'm checking from this pinned tube socket pin to the top of the grid leak resistor. And as you can see, if I can get a good connection on it. So let's see, could be solder joints here and here, which I've read those may be an issue, but let's see if we can, well, having to reach around the camera. Well, I'm going to have to use what the 1920s repairman would have used, warplers. So anyway, let's see if we can just work that loose, and oh, we're getting different results already, aren't we? That sounded nice. Let's see. Now we got 1K. We can just, what I've got to do is I got to take that grid leak resistor out and get a screwdriver on there. Hang on. For whatever reason, that solder joint there won't allow me to get my nut driver on it. I doubt that a technician in the 20s had a nut driver. let's try this. Let's go over here and see if it's this. Maybe this. So I believe it's that sort of joint right there. What do you think? If we go back here, we're reading 360, 500 ohms. Go here, we're reading approximately the same. We go right here. Yeah. Get on it. It's 19. Let's get on the connector itself right there. There's something in this. I'm going to take this off and we'll look at it and see. I've taken that nut off and we go to the loop itself. And we're down to like 0.5, 0.4, which is probably my leads. I think this may be my biggest issue, probably in all of them. This is a lock nut, a lock washer, and it is rusty. So I believe just about every one of these up through here has this particular washer on there. I think it would behoove me, this looks like a good nut. I don't see a problem with it. I believe if I had some of these, and I may have some in the shop, I'll have to go look, but nonetheless I'll go down to local hardware and get some of these and change all these out. I think that's going to be key in not chasing my tail down the road. Let's get all good connections, and then we won't have to worry about that later. Does that make any sense? I know it sounds a lot of little piddly work, but I tell you, one of the biggest causes on radios, and Josh, my bud W4FLI, when we're working on old radios and got a problem, first thing we ask each other is, do you clean the tube sockets? Maybe, well, let me check. Come back, and that was it. A lot of the times it's a bad connection, especially these things been sitting around for a while. And with this, as you can see, look what's coming off on my fingers. I wash my hands every now and then, but that's pure rust, and there's no way it's going to cause a problem, maybe a possible diode in there, you know. It's going to cause resistance, and for a signal to go through this thing, you're going to need as less of resistance as possible. Okay, changed out the lock washer, and you can see that it improved the continuity. All right, I went through and I checked L1s, L2s, L3s, and I get continuity, but I get some inconsistent readings. They're not open, but you remember the washer issue, the lock washer issue. I believe that's where the issue's at, and I know they're not open, so that's a good thing, but the exact value, I'll have to go back and get it when I change those washers out. So I think we're going to go ahead and end part 2 and let you guys look at this, analyze it, see what you think, come up with any suggestions or whatever. Like I said, I've got the replacement transformers ordered for these two, and I'll change the connections or the washers and get good connections, rework that power supply according to Bob. Everybody knows Bob. And there's another thing I may try to protect my new transformers from the tubes. And I may not use transformers. I may use resistors and capacitors to couple the stages. We will lose the amplification. The transformers do a little bit of amplification because it's a step up transformer, because it takes the AC voltage from one stage and steps it up to the next stage. And so you get a little gain through the transformers. But I believe we can use resistors and a capacitor to couple them together and try the radio. And that way we can check the current, make sure the tubes are working before I put $25 transformers in and burn them up. And so that may be what we'll want to do in part 3. But in part 3, we'll take these transformers out, do all these new connections, work on that power supply, and we'll try to bring it up. We'll try to bring this up. So tell me what you think. Hit the like button if you like it. That'll set the algorithms for other folks and all that good stuff. Thanks all my subscribers, and thanks for all the comments. Got good feedback, got good information, and there's an article that Jim sent me, and I'm gonna post it on the next video, and it shows how to utilize this, how to operate this thing, which is very, very informative. It's a good read also from the time. It was an article. So, and I appreciate Jim for submitting that to me. And here's his YouTube channel. And so I believe that's it for part 2. Can't think of anything else. Alright, so from Larry, from the hills of Tennessee, thanks for watching.